friends, welcome to Think Maths. In this session, we are going to discuss about exercise 1.4 question 1. So question 1 says that without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion. Okay, so here we should not divide this way, that is whether 13 is divisible by 3125. So usually we will divide in this way and we will get a quotient, and then we will check whether the decimal expansion terminates or not. Okay, so now this is not the case. Now we have to check the denominator. Already in theorem 1.5, 1.6, 1.7 we have discussed the theorems, that is if the decimal expansion of the denominator, that is q, in p by q, if q is of the form 2 power n into 5 power m, then we can say that this decimal expansion terminates. In reverse manner also we can say, that is if the decimal expansion terminates, then q will be of the form 2 power n into 5 power m, where n and m are non-negative positive integers. That is n and m will take the values 0, 1, 2, etc. Okay. So if q is not of the form 2 power n into 5 power m, we already proved that then the decimal expansion will be non-terminating repeating. Okay. So we have to use the theorem to perform this problem. Okay. So the first problem is 13 divided by 3125. Okay. So 13 is a prime number. So this cannot be factorized. Now we will factorize 3125. So 3125. So as in ends with 5, I take the prime number 5. So 5 6 are 30, balance will be 1. 2 5s are 10, balance 2. 5 5s are 25. Again I take 5. 5 1s are 5, balance 1. 2 5s are 10, balance 2. 5 5s are 25. Again 5 can be taken. 5 2s are 10, balance 2. 5 5s are 25. So again 5, 5 5s are 25. So 5, 1. Okay. So this 3125 can be written as, how many 5s are there? 1, 2, 3, 4, 5. So 5 to the power 5. So instead of just writing 5 to the power 5, I can write 13 divided by 2 power 0. Anything power 0 is 1. 2 power 0 into 5 power 5. So this is of the form 2 power n into 5 power m. So we can say that this decimal expansion will have a terminating expansion. Okay. So here denominator 5 power 5 is of the form 2 power n into 5 power n. So n takes the value 0 and m takes the value 5. So the rational number has a terminating decimal expansion. So next value is 17 divided by 8. So 8 can be easily written as 2 into 2 into 2. So this is nothing but 17 divided by 2 power 3. So there is no power for 5. So we can write it as 5 power 0 because 5 power 0 is 1. So this is of the form 2 power n into 5 power n. So using the theorem we can say that rational number 17 by 8 is the form 2 power n into 5 power n. So this rational number has a terminating decimal expansion. Okay. So next problem. (64 by 455). First we have to expand 64. So 64 is an even number. So I take the smallest prime 2. So 2 3s are 6, 2 2s are 4, again 2, 1 2s are 2, balance 1, 6 2s are 12, again 2, 2 8s are 16, 2 fours are 8, 2 twos are 2. So 16 can be written as, how many twos are there? 6. 2 to the power 6. Next, 455. So this is ending with 5, so I take 5. So 9 fives are 45, balance 1. So if I take 3, 3 threes are 9, there will be remainder 1. So I take the next prime 7. So 1 sevens are 7, balance will be 2, 3 sevens are 21. So I take 13, 1. So 455 can be written as 5 into 7 into 30. Okay. So this 7 into 13 doesn't express in the theorem. So we cannot say this decimal expansion has a terminating decimal expansion. So it has a non-terminating repeating decimal expansion. Okay. So this is of not of the form 2 power n into 5 power m. So this rational number has a non-terminating repeating decimal expansion. Okay. So next one, 15 by 1600. So this 15 can be written as 3 into 5 divided by, so we have to factorize 1600. Okay, so I take the least prime 2, 2 8s are 16, this 0 comes down, again 2, 4 2s are 8, so 0 0, 2, 200, again I take 2, 100, so again 2 is taken, 5 twos are 10, 0. Again if I take 2, 2 twos are 4, balance 1, 5 twos are 10. So I take now 5. 5 fives are 25, so 5 ones. So this can be written as, how many twos are there? 1, 2, 3, 4, 5, 6. So 2 power 6 into 5 appears 2 times, 5 power 2. So this denominator is of the form 2 power n into 5 power n. So we can say that this rational number has a terminating decimal expansion. Okay, here n takes the value 6 and m takes the value 2. Okay, so next problem, 29 by 340. So 29 is a prime number, so we need not factorize this. Let us take 343. So 343, which number it goes? 343. If I take 3, 1 3s are 3, again 1 3s are 3, remainder will be 13. So 13 is not divisible by 3. So 5 cannot be taken. Next I take 7. Okay. So 7 4s are 28. Balance will be 6. 7 9s are 63. So 49 will be in 7 table. So 7 7s are 49. So 7 1s are 7. So 29 divided by 7. So the denominator, there is no 2 and no 5. So we cannot say that this decimal expansion has a terminating expansion. That is, if it q is not of the form 2 power n into 5 power n, then the rational number has a non-terminating repeating decimal expansion. Okay, so 2 and 5 doesn't appear in the denominator, so we cannot say that denominator has terminating expansion. So it has a non-terminating repeating decimal expansion. So next problem is 2 power 3, no, 23 divided by 2 power 3 into 5 square. So already they factorized this. So the denominator has 2 power 3 into 5 square. That is, the denominator is of the form 2 power n into 5 power m. Here n takes the value 3 and m takes the value 2. So this rational number has a terminating decimal expansion. Okay. So let us go to the next problem. 129 divided by 2 power 2, 5 power 7, 7 power 5.
So let us factorize 129. So denominator is already factorized. So let us factorize 129. 129, I think it is divisible by 3. 3 fours are 12, 3 threes are 9. So 43 is a prime number. So we can stop here. So 129 can be written as 3 into 43 divided by 2 power 2 into 5 power 7 into 7 power 5. So here 7 appears. So we cannot say that this rational number has a terminating decimal expansion. That is, it has a non-terminating repeating decimal expansion because 5 appears in the denominator. So the rational number has a non-terminating repeating decimal expansion. Okay. So next problem, 6 divided by 50. So let us factorize this. So 6 can be factorized as 2 into 3. And 5 can be factorized as 3 into 5. So the 3 gets cancelled. So we can write as 2 divided by 5. That is, the denominator can be written as 2 to the power 0. Anything power 0 is 1. So 2 power 0 is 1. 1 into 5 power 1. So this is same as 5. So this is of the form 2 power n into 5 power m. So here n takes the value 0 and m takes the value 1. So the rational number has a terminating decimal expansion. Okay. So let us go to the next problem. 35 by 50. So 35 is factorized as, what is the factorization for 35? It is 5 into 7. Factorization of 50. So let us factorize this. So I take 2. 2 twos are 4. 5 twos are 10. So 5 into 5, 25. So if I take 5 outside, this 1. So denominator can be written as 2 to the power 1 into 5 to the power 2. So this is of the form 2 power n into 5 power m, and n takes the value 1 and m takes the value 2. Okay, here m takes the value 2. So the rational number 35 by 50 has a terminating decimal expansion. So next problem, 77 by, so here just a minute. Here we can cancel 1 5, that is 5 into 7 divided by 2 into this 5 square is nothing but 5 into 5. So 1 5 can be cancelled. So 7 divided by 2 power 1 into 5 power 1. So here also is of the form 2 power n into 5 power m. Here n takes the value 1 and m takes the value 1. So we can say that rational number has a terminating decimal expansion. So next problem, 77 divided by 210. So 77 can be expressed as 7 into 11. So let me factorize 210. So 210, I take first 2. 1 2s are 2. 1 doesn't go. 0. 5 2s are 10. So next I will take 5. 5 2s are 10. 1 5s are 5. So this 21 appears in 3 table. 3 7s are 21. So 7 ones. So here the decimal factorization of 210 is 2 into 3 into 5 into 7. Here 1 7 gets cancelled. So it will be 11 divided by 2 multiplied by 3 multiplied by 5. So here 3, an extra 3 appears here. Okay. So the decimal expansion is not of the form 2 power n into 5 power m. So the rational number 77 divided by 210 has a non-terminating repeating decimal expansion. Okay friends, that's all for this session.
Thank you for watching. So if you are able to follow my classes, just like, share and subscribe and hit the bell button so that you will get the notification whenever I upload my videos. So thank you for your support.